Most systems now are data-driven, and this is over in terms of the amount of data that you deal with it in real time. So if you put all of this, and if whatever your domain expertise is, if you apply this sort of these 5 points here, you say, yes, we are dealing with complex system, and the complexity of this system is increasing day after day. So again, as I'm saying, whatever your domain is, if you're working in supply chain, airlines and airports, utilities, smart cities, manufacturing, healthcare, any of those systems, whatever I'm going to say now applies to those systems, right? And the list is very long. The list of those systems is very long. Hospitals, as I'm telling you, a university like that, I can model it as a system as well, a library. All of those like a complex system, whatever I'm going to say in this lecture applies. So let's try to understand that concept of what we heard in the previous session, the word digital transformation, right? This digital transformation, everybody is recognizing as a way to manage complexity of systems. So what is digital transformation? As I'm writing here, it's a process of integrating digital technologies into all aspects of the organization, from operation to strategy and the culture, to improve the performance. Right? This is the definition of digital transformation. It's like integrating digital technologies in all aspects, from operation, strategy, and day-to-day operation. So if you look about projects for digital transformation, I come from my expertise, the project that I work with under this big umbrella of digital twins, I can classify them into those 4 categories. The first one is what we call data warehousing. Right? So a lot of companies now try to get their data, structure the data the right way, right? Try to make the data ready to get like the gems out of the data, right? So this we call it data warehousing. And most companies right now, especially in the Middle East here, are in this stage. How to collect the data and warehouse this data to represent the operation of the business domain. The second type of project was started to emerge also, which what we call data exchange. So data exchange could be like multiple cities close to each other, and they exchange data with each other, right? Could be multiple organizations, maybe Department of Energy with Department of Transportation, maybe with security. All these departments share data with each other, trying to create what we call integrated situation awareness. So say, for example, like a flooding event with the transportation, right? So flood happens, what is the impact of the transportation network, right? So now the people of like water resources are talking the people of transportation, right? So integrating data together to create better situation awareness. The third one, which is my topic about, is related to the decision support system. Decision support system, and this is what we call the intelligent layer in the digital transformation. And digital twins is falling in the decision support systems. It's part of creating intelligence in the ecosystem. And of course, the last component here is what we call the process automation. Once you know what you're going to be doing, you can automate the process, right? You don't need to include human in the loop anymore. So this is kind of like this is the overall picture of what we mean by digital transformation, different projects, and how so the different layers or the different pillars of digital transformation. So again, this is what we are focusing on today in my lecture here, which is what we call the digital support system. Right? This is the intelligence of the process. So here, as I'm writing here, digital twins falling under that pillar, the pillar of digital support systems, and they represent the intelligence core of digital transformation. Right? The intelligence core of digital transformation is falling here. So this is what we are doing here. We are linkage data with models, with decision making for continuous improvement and resilience of our systems. So how can digital twins can help? Of course, enhancing decision making. Digital twins could be a tool that help in enhancing decision making, providing predictive capabilities, right? So this is another capabilities of digital twins. optimize the performance of the system, do a lot of what-if scenario testing, stakeholder engagements, so you can engage the stakeholders of the system, and of course improve resilience. So all these digital twins, if you have a problem with any of those, the digital twins can help. I believe this is one of the most important slides in my talk today. So people are very eager to go to Shahba and say, I want to build a digital twins for my system. I want to build a digital twins for my system. So my advice to them before you go and invest in building a digital twins, just to go make a check mark for all those 9 boards. The first point that you need to check is you are dealing with a system that its performance matters, right? So dealing with a system that having high performance of the system is something that is important to you. And this performance could be measured many things depending on the system. From an infrastructure perspective, I talk about safety, I talk about service quality, cost, amount of energy that we are consuming, emissions, resilience. So here we talk about performance matters. The second one is that when you say, my system is complex and interdependent, right? It's not intuition, it's not easy to come up with an optimal strategy, right? It's a very complex, right? Some systems are very easy, right? Like you can meet an expert without doing any models, without building any digital twins, can tell you, do that, right? But some systems are really complex, many components interacting in a very non-linear way, in a stochastic way. So if you have a system like that, yes, maybe this is another check mark that your system could be eligible for building digital. The third element, or the third check mark that you want to do is that your system should be measured, right? You could have you have some sensors, you have some cameras, something to tell you what is happening in your system right now. So this is another check mark that we need to check. If you don't have a system that you cannot install the sensors on it, cameras on it, something to tell you what is happening, it will be harder to build a digital twin because you're going to be shooting in the dark. You don't have anything about the system. The fourth check mark is that your system should be controllable, right? Meaning that there is a way to control your system, right? You have a lot of demand, you have a lot of supply, there is congestion in the system, how to control that, right? Some systems are very hard to control, and some systems are controlled. So to build a digital twin, the fourth point that we need to check is to say that yes, my system is controllable. A fifth point is that again, the system is dynamic. It varies over time, right? And it's highly dynamic too. There's a neighboring country here is asking my consulting to build a digital twin for a system that I'm not sure should I accept that project or not, because it's not really dynamic, right? Now check all these 9 points, it's not really dynamic, but it's a dynamic but very slow, right? The things are not changing at a very high rate. So this is another point here. Of course, the system is uncertain and variable, a lot of uncertainty, a lot of variability, disruptions could happen. So this is another check point. One of these things also, maybe you can think about the traffic network, right? If you think about Muscat network, for example, the traffic, how it moves in a network like Muscat, if we apply all of this, you say yes, traffic network is a system that we can apply addition to. Point number 7 here, we say it's modelable, so I can build a model to replicate that system, right? It's a system I can capture its characteristics in a model. Point number 8 here, we say it's a syncable. Syncable means I can take the real world data and sync it with the model in real-time fashion. Right? So this is what the model is, the system is syncable. I can get real world observation. And of course, when you compare the cost of building that digital twins and the value that you're going to generate from that digital twin, of course, the value has to be greater than the cost. Because these digital twins, sometimes they are expensive to build, so we need to make sure that the value added from the digital twin is high. So, how the digital twin is, you can think of this slide to explain us digital twin. So I have a real-world system, whatever that real-world system is, and I'm building a digital twin for that system. And This is kind of like the interface between the real world and the digital twin. The real world will send real-time observations, right, to the digital twin, and the digital twin with all the intelligence that's built in will feed back the smarter decisions, right? Feed it back to the real world system. So this is kind of the idea, and it's a continuous process, right? It's a real-time system in most cases. Data goes to the digital twin come back with decisions. It's a closed-loop system. So you can always start from some physical system, like a traffic network, I would say, a traffic network, a hospital. So this could be a physical system. Physical system are generating data out of it, using whatever sensors, cameras, right? And then we create a virtual reality output for that system. And then use that virtual reality to come up with optimal decisions, and then control the strategies, and these control strategies go back to the physical system, right? So it's kind of like a closed loop, from the physical system to data, to the virtual world, to the decisions, to the control, and back to the physical system. So it's kind of like another different way to look at this slide. Yes, it's to go from the system to the digital twin, data, and then back to the decision. This is what I'm showing here again in different way. So this kind of like loop here go from the physical control data to the control. This is what we call the digital twin, right? Okay, so what are the elements of digital twin? So now we understand the concept of a digital twin, right? It's kind of like a replica of a real world, and I'm trying to use this replica in real time, right? To be able to give me optimal decisions about how to optimize my system, right? So this is the idea of a digital twin. What are the components of digital twins? So digital twins, in most cases, consist of all these modules. An estimation module, or called the estimation engine. Another module, we call it the consistency checking module, the prediction module, the system support module, the user interface, and then of course we would have a human in the loop. So those are the different components of digital twin. Let's go one by one. What is the estimator is? The estimation engine is kind of like the module responsible for situation awareness. The module responsible for building situation awareness about what is happening now in your system. Right? So this is kind of like a module that is replicating the current system right now minute by minute. So usually it's a work clock synchronized model. So a model that runs in real time and is synchronized with the real clock, and it receives real-time data from the system itself. So it's a model that's synchronized in the real clock and receives real-time data. So this slide gives us like an idea about that model here. So as you can see, the thick yellow line that I have here is this is how my system is behaving in the real world, right? And there is some observation coming from that system. The other one, the thin line here is the model that I'm building to run in parallel with my system. And of course, model is a model, right? Model is a model. We will try to calibrate it to the best of our abilities, but for some reason we will see some drifting happen between the real world and the estimation module, the model that we are building. So in this case here, we activate what we call the consistency checking module. So the consistency checking is always looking for if the model is drifting from the observations that we are getting from the real world, we try to correct that in real time, right? So this is another task here, we call it online calibration. I am calibrating the parameters of my model in real time to make sure that I'm not deviating, right? So this is again, could be the state of an electric grid, and this is my model for the electric grid, and I see that the model is saying something, the sensors in that grid is saying something, so I want to discover why this discrepancy, and the fix is a model to return it back to give me good observations about the real world. So this is now, the first one is what we call the estimator. So the estimator is kind of like, give me second by second, minute by minute situation awareness about my system. The next module is the prediction engine, right? So now I know what is happening in my system minute by minute. The next step is I try to predict it quickly what can happen. Why we are predicting? Because we are trying to be proactive, right? I don't want a disaster to happen and then I want to react to it. I'm always going to know what can happen in my system in the future. So this is kind of the idea of the estimation. Is what I'm having here on the x-axis here. Like this is my estimator module. And at any point in time, I can go and run a predict, right, to predict it for the future. And the estimator here is giving me a snapshot of what is happening in the system now, so I can say, this is the current situation of the system, this is the current state, and I predict it for the future. This is what we are doing here. So we have as if we are taking a snapshot of the system in the memory, and see that memory to the predictor, so the predictor doesn't start from any like initial condition. We know the initial condition that we need to predict in the future. And I can do this like prediction, either I do it every 5 minutes, every 10 minutes, or to be on demand. Whenever I need to predict, I just invoke the predictor. So this again here, I'm going to have a state of my system for the next half an hour, for the next hour. So say for example, if we talk about a transportation network, a traffic network, I know what is happening now, I know what's the condition, I know everything, but I can also predict what can happen in my network for the next half an hour. Maybe next half an hour, employees going to go out from their work, right? So the demand will be more in the network, the congestion will be here and there, right? So I kind of build a future idea about how my system will look like. And then here comes the decision support part. So if this is what you see can happen in the future, can we come up with an optimal strategy, right, to avoid any problem that can happen in the future? This is the role of the decision support engine. It's like take that prediction state and then try to come up with a scheme, right, an optimal scheme to avoid the problem before it happens. Right? So this is kind of the idea here. If we try to put all these components together, it gives us a system like this one. So this is a system, traffic management system that I built for City of Dallas. Right? So this is the network here of the DFW region. This system was deployed by Texas Department of Transportation as part of a demonstration project that was supported by US Department of Transportation. So what we do here, you see all the components that I talked about. You can see the estimation module. So this is the black horizontal line. It's kind of like we are running a simulator in real time, just to estimate what is happening in real world. At any point, we have consistency checking. Those are the green dots that whenever I see my model is deviating from the real world, I invoke this consistency checking to improve my estimation one more time. And then, as you said, I could have this like a rolling horizon framework to predict for me the future. And this predictor has to be very fast, right? Because I'm predicting for 1 hour in maybe 1 minute, right? So the gray length here is like just 1 minute, but I can predict it for 1 hour. And then based on the prediction, you can, whatever AI technology that you are good at, use that AI to come up with an optimal scheme, right? And that scheme, of course, will go to be deployed in the real world network, and your system will sense that there's a change happening in the control, and so on and so forth. So the system will keep moving 24 hours 7 as a decision support system for traffic management. One project that we're working on right now is called the Panorama project, which stands for an interpretable, context-aware AI framework for integrated real-time intersection detection and signal optimization. So the idea, if I go to the traffic engineers in the city of Nizwa and tell them, you know what, city of Dallas, any city, I tell them I'm building an AI agent that can optimize the traffic light at any intersection. What do you expect to hear from them? Yes, this is good, but how can I trust? I cannot think of AI agent and put it just in this high liability, right? So we were trying to propose to build a digital twin, or what we call digital replicant, to help test our AI algorithm before we go to the cities and say, okay, go try this or try that. So the idea here is, yes, we have an intersection. That intersection has a traffic light with some controller. This intersection has some cameras. This cameras collected the data for me from the intersection. And then, based on the state of the intersection, I will try to come up with the optimal control, optimal timing plan for the intersection, right? So it's kind of like a closed loop here. We have intersection has some kind of surveillance, and surveillance has the control. Whatever control that you come up with, you have to send it back to the intersection, right? It's a closed loop. So we are trying to mimic that closed loop somehow so we can test our AI algorithms if they are working or not. So what we are doing here, we are bringing a traffic simulation model. Somebody has done traffic simulation model, and we are integrating that with a gaming platform. Somebody worked with Unity before as a gaming platform, right? So we synchronize them together. So now I have the real world intersection here, and this is I have a camera installed in one of the corners at the intersection, right? So now I'm creating a replica of an intersection that has a camera that looks at what's going on at the intersection. And the good thing about virtual reality here is that I can test my AI logic or algorithm if it works under different scenarios. Like, so maybe like the logic is working very well, the surveillance working very well when it's morning and it's clear. How about when it's raining or snowing? Does the AI will still work well or not? So here, this is what we're doing. I can go replicate a lot of scenarios here related to rain, snow, darkness, right? So I want to test my AI if it's working under different environmental conditions. Of course, like I cannot do this in real world, right? I want to test if it's a light rain, what can happen? If it's a light snow, what can happen? Right? So this tool here, this digital replica that we are building, helps us do all of that. Where we are in the project right now, so this is kind of like one more thing here. So once we have this replica of the intersection, now I can apply computer vision tool to help me detect how many vehicles I have from the different approaches, right? So now I can, this is test my surveillance. How many vehicles in different approaches, what is the queue length here, what is the waiting time here? Because all this is the information that I need to start as a state variables to go to my AI algorithm. If somebody working with reinforcement learning or something, so this is the state variables that I can collect from the intersection using the camera. We are working right now on the next step of that, which you have to take this information from the camera and feed it to a reinforcement learning agent, so to come up with the optimal control strategy and then feed it back to the simulation. This is the step that my students are working on right now. So this is just a quick overview of what we mean by digital twin and one example of how digital twin can be applied for real-world application. Any questions? Thank you so much. Thank you.
Thank you, Professor Khalid Abdelghani, for that truly inspiring and insightful keynote address. We will now proceed to paper presentation session 1. Dr. Arab Yassami will now give to Dr. Khalid Abdelghani the certificate.
Thank you, class.
So now, thanks again, Professor Khalid Abdelghani, for the truly inspiring and insightful keynote address. We will now proceed to paper presentation session 1. which will run in parallel across multiple venues at Shahba Auditorium, Al-Bashara Hall, and Building Number 2, in Seminar Halls 1, 2, and 3. In addition, tutorial session 1 will be conducted concurrently for interested participants in the Temple Lab near the Mosque Building Number 8. Full details are available in the Isaa 2026 Conference Program Schedule book. Kindly refer to the schedule and proceed to your respective venues. Our conference volunteers will be available to guide you. After the paper presentation sessions, a lunch will be organized in the Hazan Hall. It will start at 12:45. Please join us. After the lunch break, please return to Al-Shahba Auditorium at 2 p.m. sharp for the keynote session 2. Thank you.
Сейчас, пап.
May I request the participants in the back to come in the front seats, please? Thank you.
Good morning, everyone. I am Dr. Shankar, and from University, along with me, Dr. Abdurrahman Antani from University of Nizwa. We are the session chair for this session. So we will begin the session. We have totally 5 research paper presentation, and each paper will have the time of 15 minutes, and the 15 minutes we will have 12 minutes for presentation and 3 minutes for question and answer session. So the first presentation is a lightweight predictive analytics framework for real-time big data decision-making using Packing Spark by Mohammed Abu Qawsa.
الثاني او الثالث الثاني اللي فيه
Will we have Mohammed Abu Qawsa?
يغلى قدرك.
Yeah. The second presentation is deep reinforcement learning, DRL for RDF exclusion plan optimization applied upon online games. Overall, and Charlie. Okay, then the third presentation, determinants of learner satisfaction and enrollment in MOOCs, evidence from Coursera metadata. From Emina, please. Where is your presentation?
Should I bring my laptop with the slides? Sorry. Respected organizers of the Isaa 2026 conference, respected audience, respected professor, respected mentor, Dr. Noor Kashik. It is my pleasure to apparently be the first one to present in this panel session, and I hope you will find my research interesting. My name is Emina Mekic. I'm originally coming from Bosnia and Herzegovina. I'm a PhD student at Sultan Qaboos University at the Information Studies Department of the College of Arts and Social Sciences. The topic of this research is about the determinants of learner satisfaction and enrollment in massive open online courses, and we will briefly evidence from the Coursera metadata. So here are actually the sections that will be covered within this presentation. So through the introduction, problem statement, research questions, I will present you the hypothesis, proposed methodology, or used methodology, the statistical procedures that were applied in this research paper, and we will conclude with research and discussion and future work ideas. To start with some background information, we all heard about the massive open online courses. They emerged in 2008, and there was a huge outbreak and interest in them. There is a criticism for the massive open online courses that they are actually having a high dropout. However, they remain relevant in nowadays education and professional development as well. I would like to confirm that. I would like to draw your attention to the Future of Jobs report, which actually states that 39% of our current skills will have to be transformed by the 2013. With AI and big data skills actually taking the leading place, meaning that the skills that we currently have will have to be kind of empowered and engaged with the AI and data skills.
Speaking of the future of the universities report, this report actually predicts the future of universities and how the modern universities by 2040 will look like. And MOOCs are actually taking a big part here. This report predicts that actually classroom communication will have to be transformed, and the learner and the instructor role will have to be retained. The MOOCs will have to be integrated in the everyday learnings. So therefore, this study kind of grasped all these ideas and wanted to learn the effects that can be presented through the metadata report that was obtained from the Kaggle repository, about which I will say a few words later, to investigate the following things: effects of course learning on the satisfaction and enrollment of the learners in massive open online courses. And we wanted to grasp the idea of differences in these patterns between AI-focused MOOCs and non-AI or programming MOOCs. So research objective is actually to examine the direct and moderating effects of MOOC course characteristics, specifically the course length indicated by the number of modules and course topic, differentiated by AI and non-AI MOOCs, so on learner satisfaction and enrollment. So these ideas are actually also grasped in the latest Coursera report, which of 2026, which is saying that actually MOOCs are bringing the career and personal benefits to its users. And there is an increased demand of generated AI-related courses, which result in the user actually report the strong labor demand and competitive advantage after the completion of the MOOCs that are related to the AI competencies. Therefore, we are asking from the metadata that we are asking the following research questions. So what is the effect of the course length measured by the number of modules on learner satisfaction and MOOC enrollment in technical MOOCs? What is the relationship between learner satisfaction and MOOC enrollments in technical MOOCs? And does course topics, AI-focused versus programming or other non-AI courses, moderate the relationship among course structure, learner satisfaction, and MOOC enrollment? Speaking of the literature review, there are two baseline theories that are applied in this research. First one is actually expectation confirmation model. This model states that, and we here view the MOOCs as the information system, that for the success of the information system and for the continuous intention, the predictors are expectation, perceived usefulness, which will lead actually to satisfaction. Satisfaction will lead to the continuous intention. In this research, we have MOOC satisfaction and MOOC enrollment as the actually idea of the continuous intention. Another baseline theory that we are applying in this research is actually instructional design theory. In this theory, actually, and you as a scholars and as a professor, I really know this very well. So the course length, sequences of the idea, how do you transition through the course topic is really impacting the knowledge of association of the students. So therefore, we have 6 hypotheses to be tested in this research. The first 3 hypotheses are actually checking or considering the direct effects of the learner satisfaction between the variables learner satisfaction, MOOC length, and the MOOC enrollment. The preceding hypothesis 4, hypothesis 5, and hypothesis 6 are actually checking the moderating effect, as we said in the opening part of the MOOC topic. Whether these effects are higher in the AIs that are from the AI, in the MOOCs that are from the AI topics, or those that are coming from the programming topics. So for the proposed methodology, so for the data collection, as we said in the very beginning, this research is based on the metadata collected from the Kaggle repository. Therefore, this is a secondary data. So it is a Coursera users metadata report. The initial report had more than 7,000 entries. after the data cleaning, normalization, and removal of any missing data, we prepared a set of 3,572 entries. Model design, you can see the model design on the slide. However, selected variables in the available data set were renamed. Domain was renamed to the MOOC topic, rating was renamed to the learner satisfaction. Number enrolled was actually renamed to MOOC enrollment, and number of modules is actually renamed according to the instructional design theory to the MOOC land. MOOC topic in this research was actually encoded in binary variables of AI versus non-AI into 0 and 1 for the piece of the research. So evaluation, we perform both descriptive statistics and inferential statistics, which we will report in the preceding slides. So in the descriptive statistics, it is actually mean, the standard deviation, mean, modern maximum, and for the inferential statistics, we use smart VLS for zero regression and moderation procedures through the process of bootstrapping. In this research, actually, as we can see, MOOC length is an independent variable, while learner satisfaction and MOOC enrollment are dependent variable, and the MOOC topic is the moderating variable. So here are after the statistical procedures mentioned just a minute ago. Here are the results that we obtained. As we can see, actually, from the descriptive statistics, speaking of the, for example, learner satisfaction, we see that actually learners are highly satisfied with courses, varying that the maximum rating is 5 and the mean is 4.55. In terms of the MOOC enrollment, I have to say these data were really variable and they were really high, ranging from few 100,000 to few millions. Therefore, we performed a great transformation to this data in order to present it in a more normalized way. So speaking of the MOOC enrollment, mean is 4.29, saying that actually there is a high, and there are courses with a really high enrollment. And in terms of the length, we will pay certain attention to that in the preceding slide, but we can see that actually course length in terms of the number of modules is actually ranging between 1 and 16. Another descriptive statistic report that we would like to say here is the actual frequencies of the MOOC topics. So among the 3,000, as we can see, 3,572 courses that were part of this metadata report, majority of them are actually AI courses. So we already see this shift and the trend in actually recognition of the learners that these skills are highly needed and we need it today. And it is actually in line with what we heard in the introductory part of this conference. 25% of the courses are actually more of the programming or non-AI courses with the topics like Java, Python, web development, and web development. Speaking now of the regression analysis and hypothesis testing, we see that actually we have 4 hypotheses accepted and 2 rejected. Speaking of our direct effects, where actually learner satisfaction affects the MOOC enrollment, meaning that actually if you as a learner are highly satisfied with the course, you will plan to enroll in another MOOC courses. That the MOOC length is actually highly relevant to the learner satisfaction. So literature actually confirms that that the prerequisite for the learner satisfaction is not actually the short MOOCs, but rather the MOOCs that are kind of scattered in a quality way, and that the big blocks and big chunks of the ideas are broken down into smaller parts that are easily comprehensible for a learner. Finally, for the hypothesis 3, which is accepted, is that actually MOOC length again affects the MOOC enrollment. This is a critical element for the MOOC designers and the MOOC providers, that actually MOOC length and the number of modules is something to be thought of in speaking about the computer science MOOCs. For the moderating effects, we actually found a really interesting result that the MOOC topic actually moderate the relationship between MOOC length and learner satisfaction. Then we were asking ourselves which topic, because we broke our set into AI and non-AI topics. And what we found that actually there is a slightly higher association between MOOC length and learner satisfaction in non-AI courses. So meaning to say that students that are taking the Java programming, web development courses are a bit more sensitive to the length of the MOOC, to how the model is organized, how actually the big ideas are broken into transition models. We were going further with our open-mindedness and our questioning and how we can utilize these results, and we were asking ourselves, so is there now the optimal number of models that we, through this research, can suggest to the practitioners and to the researchers? And with quadratic regression, actually we found that based on this number, which is 3,572 reports, actually the suggested number of MOOC length is between 8 and 12 modules. So after 12, actually, we see a decline in the enrollment, I guess, meaning that actually learners can find it a bit overwhelming and maybe hard to complete. So to summarize our findings, actually, once again, we have findings related to that direct effect, and what is in line with the previous literature is that learner satisfaction is positively associated with the MOOC enrollment, meaning that learners that are satisfied with the current standing and with what they learn within single MOOC will tend to enroll in another MOOCs as well. This is confirmed across both AI and programming courses, and support the expectation confirmation model. Another direct effect is that actually there is a positive association between number of modules and learner outcomes, such as satisfaction and enrollment. So what we can suggest is that actually well-structured course design enhance satisfaction and enrollment, which is actually contributing to these statements of the instructional design. So there is also curvilinear U-shaped relationship confirmed about the optimal number of courses, as we indicated that it is actually between 8 to 12, not number of courses, number of modules, number of length of the modules, it is between 8 to 12 modules within a single MOOC course. So moderating effects, non-AI courses, so the association between the MOOC length and learner satisfaction was stronger in the non-AI courses. And this is actually in line with the literature that we researched for, because certain prerequisite knowledge, certain applications, certain coding is needed in the non-AI MOOCs, and therefore learners might be more sensitive towards how the model is organized. So they require careful sequencing and breaking down complex topics into meaningful models. So what are the limitations and future possible work of this research? So limitations is definitely that this is actually metadata from a single MOOC platform, that is Coursera. It is a well-known and widely used, however, there are other platforms as well. This is a computer science domain metadata, therefore there is a limitation in terms of the transferability of these results from humanities to business science and similar. So another research needs to be done there. So this is a course level unit analysis, so we didn't collect any behavioral information, we didn't do any surveys, so this is a metadata report as we can give this secondary data. So what can be done in other research with reports like this? So we can check other platforms and to see whether actually these results are similar or same or different in other platforms, like it is Udacity, like it is UDX, and similar. Or even, for example, if Oman have its local MOOC platforms, this research can be applied to. So comparative studies we suggest across the platform and academic disciplines to capture associations in different learning environments. Another element of this huge report is actually, it was a textual report. Okay, it was a reflection of the users, therefore it can be used for the sentiment analysis from the current data set. So conclusion, learner satisfaction consistently predicts enrollment across both AI and programming MOOCs. Course length, as we said, is highly critical in non-AI, especially in non-AI courses, and here this research suggests it should range between 8 to 12 modules. Programming MOOCs gain more attention and benefit more from the careful scaffolding. So AI courses may benefit more from rich content, case studies, or hands-on tools. So practical guidance from this research is that actually learning satisfaction should definitely out of the question be ensured across each MOOC. Structure courses thoughtfully and adopt differentiation design based on the current course style. So the successful online learning actually combines broadly relevant factors such as satisfaction with context-sensitive instructional design. So once again, my name is Alina Mek, and if you would like to contact me about this research, here is my email. Thank you very much for your attention.
Any questions from the audience? Thank you so much for your presentations. My name is Jason International. Looking at the outcomes of research, you had mentioned that there is a direct positive relationship between the number of work sites, if I get it right, and then student satisfaction and results. Then, however, on the indirect relationship, it looks like there's a difference between the AI and the function. And then my little concern is how do we arrive at the issue of when we say outcomes, since that one is very difficult.
So, realistic progression was the suggestion from the yeah. Yes, so the quadratic progression should be kind of a suggestion of a reviewer of the paper in order to show the actually the strength of the plane that there is of the number of previously we used a simple statistic to show that. However, they suggested us to use this function. We performed two quadratic progressions, to be honest. In order to really with the deeper side. So we tested both MOOC length and MOOC length and MOOC satisfaction, which is really now coming directly to your question. So both of them actually showed the relation, the U-shaped relation. However, in terms of the MOOC length and MOOC performance, this relation and this association actually is secondary about the relationship was more profound. This is why we reported it. Yes, just
Okay, so how does it relate to the global practice for the local policy? It's finding that, like you were saying around 12, right?
up to 12 we start.
Yeah, so how does it align with local practice or maybe a local practice?
So we can definitely align with the global practices because the idea was actually taken from the method. Okay, so these are actually the practices of the Coursera courses. Okay, so these are the lines that are reported within the Coursera cohort MOOCs. Speaking of the Oman, to be honest, I don't know the information. I do not give very much information how they organize their courses, but this is valuable insight that we provide to offer to the Oman MOOC providers.
So from the literature, we're able to get the actual standard, the number of model, and then how does it define the outcomes?
Okay. So from the literature actually suggests that, as I said in the introduction, a small number of courses, a small number of short terms doesn't guarantee actually the success, the satisfaction we want. Actually, the literature identified that the breaking these models into smaller chunks creating this complex at the end. The literature suggests even beyond 12. Okay, so for the complex ideas, it will manage actually, and it will lead to increased satisfaction anymore. So if you find that people actually, I started two studies which were actually checking this in the people. So they checked the MOOCs with a smaller number of the models and those with a higher number, and they found that the enrollment and satisfaction was higher in those that are checking the larger number. Thank you for your questions. Okay.
Any other please?
Thank you very much for the wonderful presentations. Mine have
question is something like comment or point to. Number one, when you look at from the introductions, usually you have not very stated what is the current motivation or what are the current issues you that guide you to this particular that is one. And when you look at some of such questions or objective, one of which is going to be data satisfaction. Now, when you check with your methodology, you made mention that you collected data using metadata, right?
Yes.
Now, which is the secondary data.
Yes.
But technically, from literature review, when you look at satisfaction, it's behavioral attitude variable, which usually is collected using primary data. Now, justification as to how, why we collected this data are able to use data and how this data measures satisfaction, which is contrary to what is generally we collected using data is not being collected. So maybe I don't know how I should do this, but a little bit justification as to why you're using that data. And not only that, we must know the variables, how we measure them, why we measure them, justification is actually this. So I think we can wish to look at this observation. Thank you.
So maybe just to reflect a bit on your first comment about the motivation for the research, actually it was exactly aligned with where actually some rather criticize for high workout rates, okay? Meaning like that they start, the student learners are starting at technical levels, but the sitting dropout. And actually we found motivation in that actually course structure and satisfaction is highly relevant for the MOOC study. So how, meaning that even though they are here from since 2008, there is still a lot of space for improvement in terms of how they are designed, how they are structured, and how they are actually able to provide the satisfaction. Speaking of yes, of the learner satisfaction, as you said, it is a behavioral measurement of the behavioral variable. We rely on the ratings. Okay, so maybe we can think of maybe another link of this variable which could be made reflect better this association, not represented as it was done, as you said, by the survey or something like that. So thank you, this is really valuable.
And finally, I think for the models also, because when I look at the analysis, I noticed that if I ask you how many independent variables, because the independent variables, you are like they are mixing or changing your independent variables. So looking at the model like this, the part of which is moderator.
Yeah, the moderator is good topic.
So a little bit, maybe you may wish to look at it because you keep on changing. Because from my understanding, you have like two different variables. Am I correct?
Yes.
Based on the result.
Yes.
Now, again, I can say you have two independent variables as well. So now, why is moderator? So you may wish to.
Yeah, I will be doing that. Thank you very much for your time. Should I leave? Oh. Sitting next to you. Thank you. Thank you. Thank you. Okay, so should I leave my laptop for the next presentation? Okay.
Next topic is the modular machine learning for country awareness analysis. The modular machine learning systems for country awareness analysis. Next time.
Assalamualaikum.
Listen.
Good morning, one and all present here. A very warm welcome to the chair, Dr. Manish, and co-chair, Dr. Benjamin. Myself, Dr. Nizwa from the Department of Accounting, on behalf of my colleagues, Dr. Mohammad Abu Qasar and Dr. Rabi Ramzan. I am presenting this paper today. The topic is Text Analytics for Financial Performance Prediction, Analyzing Management Sentiment in Annual Reports. Usually what we understand is the annual reports contain only the financials, but yeah, as an introduction, I was just about to tell you that the annual reports usually contain not only the financial data, but also the detailed and extended narrative disclosures where management explains about the firm performance and risks and prospects. And in this presentation today, what I am going to speak about is give you an introduction and motivation of the research, followed by literature review and related work, problem statement and objectives, proposed methodology, experimental setup and data set, results and discussion, and conclusion and future work. So to talk more about the background, let me tell you that since the financial reports are not only about the analytics, but they are also giving a narrative or a story about the whole company, these stories can be interpreted in a tone and in a mood of management and its views on the business conditions, risk taking, and what will be the future prospects. So traditionally, financial performance forecasting only depended upon the quantitative indices. The qualitative signals such as textual information were not fully exploited. And in this study, what we are doing is like we are examining these management sentiment in annual reports as the predictor of financial performance. The sentiment features are extracted from management discussion sections and they are combined to financial variables with the natural language processing method or predictive models. So this is what we are doing here, and we are trying to work out if AI is helpful in understanding the financial performance or not. So based on the previous literature, we understand that these are some of the literature that has been working on the financial sentiment lexicons. Lexicons are actually the word which have been explained, the terms have been explained. So, however, the main research objective was to examine whether the sentiment based on management disclosures can and are they able to improve the financial performance prediction when combined with quantitative financial measures. So, on the one hand, we are having the textual analytics, textual data, and on the other hand, we are having the financial analytic let us say proxies, for example, return on assets and gross profit and net profit. And so we are trying here to combine these
these two together and trying to understand what is the sentiment of the annual reports and what the shareholders or the, let us say, the stakeholders take from the annual report reading. So it is not just textual analysis, but it is also based on the quantitative data. So the previous research shows that, like you can see in the reference number 2, the financial sentiment lexicon has been the main category, and they have the data source for them is the 10K filings, usually based on US data, and domain-specific dictionary is the methodology that they have adopted. But our work adopts finance domain sentiment principles and applies them to the annual report management sections. In the second category, the tone management was studied on the corporate disclosures, and tone analysis was done, and they highlight the managerial tone effect, but they have not combined it with the financial data. So our work focuses on predictive values rather than impression management only. The text performance link, this was the category in which the annual reports were studied and the readability analysis was done. So readability analysis is just the text that you are focusing on. It shows what are the narratives in the text and whether they matter or not. But our work focus is on sentiment rather than just readability. The next paper underlined the sentiment-based forecasting. It was also based on annual reports. We are also basing our the work is on the annual reports only, and sentiment matrices were taken. But our work provides a compact predictive evaluation. The tone and font signals were studied in another paper, and they were also based on the US annual reports. It's a huge data that they have, but our data depends upon the Oman companies listed on Muscat Stock Exchange, and so there is a limited data on which we have studied. However, the similar concept is there what we are doing, but we are using the annual report management narrative and a different modeling step, which I will be showing you in the slides to follow. The financial sentiment benchmarks were taken up in another paper, and they studied the news and micro blogs, and the methodology they adopted was a shared task data set. It provides sentiment evaluation standards that motivates our experimental design also. So in this study, what we are focusing on financial performance prediction, which is very important in times now, because people, like even during the disrupting times when you are talking about sustainability, and so it's very important to know the prediction or whatever it is in the human control and whatever we can just predict. So the annual report management sections have been studied in detail, and we have used lexicon-based sentiment plus the machine learning. So it is not one directional, because textual studies, what usually we have seen is just one directional. For example, if it says that the bank on the river, so the bank is taken up as a financial institute. But what we have studied is bi-dimensional bird, and in this they study both ways. They study the right way and the left way, and when it studies the left way, it will show river and then it will show bank. It means river bank. It is not related with the financial institution, but river bank. So this is the benefit of having, let's say, bird studies and using AI. So we have used AI to study both the both right-hand and left-hand studies. So this is why we create the management sentiment with the financial indicator, and we are also using the profitability predictions, and these transformer based, like I just explained to you, these models are discussed in as future extensions, and more studies you will find in future which are related with this. The novelty of this paper is that not much work has been done using the AI for the textual analysis on the annual reports. So we have collected 23 company annual reports from the Muscat Stock Exchange, and all over going through the management descriptions and details of management discussion and analysis, almost we catch on the average of 400 words per annual report. So it comes to 9,200 words, and 23 into 7 we have done the financial data pickup. So 161 is the financial data on which it is based. These are the proxies of financial performance. So the model detail of the model design, as you can see, for the empirical evaluation which is reported in this study, the sentiment features were extracted using a financial oriented lexicon based approach. Now when I say financial oriented lexicon, it means that it is bidimensional, but it is based on fin word. That means it is only using the idea of finance in the terms of word. So sentiment features were extracted using Logarithm McDonald Financial Sentiment Lexicon. For documents, we have first taken the tokens of all the companies, and then with the help of these tokens, positive, negative tone ratios were computed, and then later on we put them into notes, and the net sentiment was defined later on. The tonal inconsistency was captured using the sentiment variability, measured as standard deviation of sentence level sentiment scores with each document. Usually in the previous research, what we are doing is we are trying to identify the codes from the annual reports. For example, if it is green finance, then we choose the word green finance, or if it is like, and we just put them in a, let us say, in an Excel sheet and trying to say, okay, how many words were related to this and whether they depict or whether they measure and what is the mean score of all of it, and whether it measures, it gives us a sense of understanding from the management reports whether they are talking about greenwashing or sustainability or these kind of things. But in this paper, what we have done is we have tried to use the bidimensional. So looking at the text and then aligning the whole text with the financial metrics. So this is how we have come out transformer-based sentiments modeling using word and fin word. So based on transformer article, this is discussed as future extension to be evaluated on larger multi-year data sets. So this is just a small sample we are presenting here, but it has a very bright future. And this is the flowchart that we have used, annual reports, and then text extraction has been made, text processing was done using tokenization and stop word removal, and sentiment analysis was based on lexicon and transformer, like I told you earlier. And these sentiment features, later on sentiment features construction was done and was combined with financial indicators, and then we did the predictive modeling. So this is how the paper moves on. The final result, the experimental results show that just when we are taking care of the financial only, logistic regression was run and the accuracy was 0.75, the FI score was 0.84. When only sentiments were run and they were studied, it was 0.74 and the FI score was 0.84. But the both together, financial and sentiment, it although it's not equivalent to the financial and sentiment, but yet it gives us a very good score. Accuracy level is near to 0.7 and the FI score is 0.8. So this is a small detail of the lexicon versus the modern word or fin word is working. I took it from ChatGPT to explain it for the say IAS or too much computer savvy people, that this approach, say lexicon method is based on dictionary, just the wordings, but word and fin word are the AI, machine learning. And the context understanding, lexicon cannot understand the context, but word and fin word, like I explained to you about the river bank and bank of a river, so they can understand it. So it's a better prediction method, and it is going to stay here, and this is the future of the financial analysis and predictions. So this is an advanced system, as you already know, and the accuracy is also really high about it. So this is how the prediction accuracy was compared and given to you. In the data set, I already explained to you, there were total 23 funds that we analyzed, and the mean sentiment score is 0.011. Sentiment profit, you saw the correlation between them is 0.28 and profit margin correlation is 0.8. Although there are a lot of limitations to what we have studied. In another key finding, I just explained to you, and the limitation for this research paper is that it was focused only on a limited sample, which in future can be extended to a large number of companies. But it gives you an idea about what is happening in Oman. Regional researchers are also as much important as we talk about the US database research. Because in the Gulf area, if you are studying in the GCC countries, it is very important for us to understand where the Gulf is moving and which direction it is moving. So it's really important to study the industries here. However, after pre-processing and filtering of firms with both usable narrative text and financial values, the final sample, as I told you, consisted of 23 firms. And some companies, some firms were excluded because either they had a print or the screenshot of the management discussions, and we could not extract the data because it was not in the extracting format. So the small cross-section sample size limits the power of statistical analysis, and it restricts the generalizability. So in future we can use more detailed, larger data. And another important thing about annual report is that it contains heterogeneously formatted text. Because it is like sentiment, it is like behavior, it is like talk. But if the text is similar, then we will always say it has been copied, plagiarism is there. So definitely there will be difference in writing from report to report. And due to this heterogeneity, we are unable to go in detail or exact text extraction, and this is why it is somewhere in the computer methodology learning. We can also say they create a lot of noise. However, the future work we can use larger longitudinal data set, and it can be validated in the proposed framework, and would also add to the robustness and the external validity. So in conclusion, what I want to end up the presentation here, I have hope I have been able to extend our thinking, our working, and research which can be carried forward by many of you in future, that we are now aligning the textual data with the financial data, and we are trying to search out some novel words. So introducing this sentiment extraction model where it is suitable for the management section of annual reports, the comparison with the traditional financial sentiment lexicons and of the sentiment for firm performance. So this is how the whole design, and thank you so much for patience listening. And my authors along with me are Dr. Abu Kausar, myself Dr. Kanis Fatima, and Rabi Ramdan. Abu Kausar and Rabi Ramdan are from the information system, and I am from the accounting department. And for any other detail, or if you need to collaborate or do research, this is the email, and we can further work on the financial data, because we have an access to all these financial information, and not much what has been done on the financial sentiment analysis. So this opens up a new area of research for everyone. Thank you very much. May I take up if you have any questions? Thank you so much. Yes, please.
Thank you so much. Topic for us is for notes and weeks. So I want to questions like this will be trial is because right?
Yes.
So I want to know how to fit is there any similar.
Yes, my name is Dr. Meawu, still from accounting, same department of the presenter. I am so much interested in the area because this is purely, or let me say, a cross-field area that captured accounting, finance, and then let me say artificial intelligence, which is purely related to the IS. So my questions is one, 10K like filings requirement, I was saying is based in US because it's one of the provisions by the Security and Exchange Commissions in US, and I believe it provides a very comprehensive, detailed disclosure requirement. So my question is, looking at the context of the paper, is related to Oman, right? From the preliminary data collections.
Yes.
So I'm just asking, I'm not deeply more, knowledgeable with the GAMS data, and I believe the presenter has more insight. So my question is how easy it is for the researchers to actually adopt a US-based disclosure requirement vis-a-vis the disclosure index in Gulf countries, looking at the status of the Gulf countries in terms of the disclosure. That's one. Then the second question is sentimental analysis is very important, especially for investors. So what are the targets of the presenters? What are they trying to develop? Is it like going to be a proposed model for Muscat Stock Exchange for them to maybe adopt so that it can help the investors to actually look at which company is the best for them to go with their money and which one is not? So these are my questions, 2 questions. Thank you.
Thank you so much for the nice questions. As far as I understand, your question number 1 is talking about we have done this research on the 10K findings, which is based on US data. Is that correct? And the second one, you are asking about whether this type of work, how it will be helpful for what is the usability of this kind of thing. So, addressing your first question, of course, we understand that it is based on, not all, our work is not based on the US listing, but the papers that we studied before finalizing our paper. That is the literature review. They have already been working on the 10K filing from the US data. And since they have studied only the textual analysis, they have only gone with the text sentiments only. They have extracted the data from the text, and this is just one-way analysis that they have done. So, looking on to the type of filing that US does, let me tell you that because of IFRS, International Financial Reporting Standards, and Oman follows definitely International Financial Reporting Standards only. So, this is why we are able to relate that work with our work. And number 2, about whether this is useful or not. So, 100% usability is there because if we are aligning the tone, if you go through the paper, you will try to understand that there are some words. For example, if I say liability, in simple lexicon, it will be, you will understand it as a negative word. But if I say assets, or if I say growth, or if I say profit, these are all positive words. But in bird and fin bird, we are going crossways. So they are able to understand the sentiment that what we are talking about. Liability is just a financial term in financial analysis. So this cannot be taken as a negative word because it may be temporary and the liabilities are there for the organizations. The risk depends upon whether the liabilities are more or less. But we have to use liabilities. We have to use because that is a cheaper source of finance, and this is why it helps the industries and firms for better growth and better profitability and so on. So this is why, reflecting to your second question, it is very important, and this kind of research is just on the nascent stage now. When we do more research on this, just not based on the Oman data, if it is based on the Gulf data, if it is based on Southeastern countries, it will give you amazing results, which will be novel idea, and it will be a breakthrough into the world of academics. So this is just the beginning, and the future is still to be seen. Thank you so much. Any other questions, please?
For Doctor, I have one very basic fundamental question. It's almost similar to his previous question. Like you have chosen companies from one. May I know what kind of companies? I think you are focused on a particular kind of companies. And as he said, can this analysis be extended to any other country, like this one? And where the machine learning concepts are used in this? You say like it's an integrated one using lexicon approach and machine learning, right? ML. So where you have used the machine learning approach? I couldn't see that.
Yeah.
Thank you.
I will respond to your three questions. So number one, when we talk about, I may have missed the first question by the sequence.
Like what kind of companies?
Yeah, what kind of companies? So the companies that we took here were all the industrial companies, and we have avoided taking the financial companies. The banking and the financial institutes have been avoided, and out of the remaining companies, because there is a limited data available in Muscat Stock Exchange, from the data which was available, we have been selectively taking the companies based on the text data available. So I told earlier that in one of our limitations is this, that if it is given in the form of a photograph, PNG, or and the text is not available to us, then we cannot extract the data and we cannot work on it. So this is one of the limitation also, and this is how we have chosen the company. Secondly, how we have analyzed what is the way of using AI was we extracted all the annual reports and the data was extracted by AI. Yeah. So the text sentiment and the tonal analysis was done by AI only. We have no role into it. Like we have not done it manually. If you do it manually, then it will take a longer time and we would not be able to do it. So AI has helped us extracting the data, also working all the tone analysis, sentiment analysis, all these analysis have also been done through AI. And how it is generalizability, that I again mentioned in my limitation also, that it cannot be generalized because the sample set is small. So if the larger sample is taken, large language modeling can be done and it can be generalized. So this is one of the limitations I mentioned. Thank you.
لا في اللحظة الجلسة اللي يا بس استاذ عادي خليه ترى بس بعدين ما نبلغ يمشي ها عادي خليه يتوكل احنا بعدين بس يقبل له يعني اسوي له انت وتوفير الفوري بس عادي توكل استاذ يسوي ترى انت في الاخير ما حد ينصف ما حد فيها لا اسوي اني اسوي عندي اوف في التلفون هي عادي هي عندي الوجود قايدين بالوقت لا قايدين راح ضيوف بعد ما قلنا نقول شوف استاذ محمد 12 الجلسة جو 12 ايوه زي خلصوا الكامل المفروض ساعة زي الرحمن لكن هم مشكلة السابق ما متخيلين خلصوا من بسيطة
Am I audible?